Hello, welcome to this presentation and update on Oracle's new features and functionality that is now available in release 12.2 of the Oracle database and in release 4.2 of the Oracle Data Miner workflow user interface, which is actually an extension to the new release 4.2 of SQL Developer. So my name's Charlie Berger. Hi, I'm the Senior Director of Product Management for Oracle's Machine Learning and Advanced Analytics. And you can reach me at the emails provided there or follow me on Twitter. And in this presentation and demonstration, I'm going to try and cover all the new highlights, all the new cool things that are in release 4.2 and 12.2. But before I go into that, I just want to give sort of a brief overview of what Oracle's Machine Learning and Advanced Analytics offerings are all about. So I'll do that for about 5, 6, 7 slides and then dive into the details of what all the new features are and try and show some brief demos of that as well. So with Oracle's Machine Learning and Advanced Analytics strategy, what we've decided to do starting kind of a while ago was that as the volumes of data grow larger and larger, and at some point you reach this stage where you say, don't move the data. The data is huge. I don't want to move the data. Instead, I want to move the algorithms. So what we do is we move the algorithms, not the data. We've taught the database how to do things like very simple, naive Bayes algorithms to start out with, and a priori market basket analysis algorithms, because those involve counting, right? The database is very good at counting. It can parallelize those counting SQL queries and then do a little post-processing conditional probability computations on top of that. And lo and behold, you have a pretty much state-of-the-art machine learning algorithm implemented natively inside the Oracle database. Now, we've also done similar things, slightly different implementations on the Hadoop platform within something we call the Oracle Big Data Appliance, are also now called Oracle Big Data Cloud Services, and in the database, it's the Oracle Database Cloud Service. So that's what we've been doing, and we've also been adding each release. We add 2, 3, or 4 major new machine learning algorithms like decision trees, hierarchical k-means clustering, support vector machines, attribute importance. One of the new ones is unsupervised attribute importance. So I'll cover all of what we have today and what we've recently added. But the main point is with Oracle, rather than what pretty much everyone else on the market does with more of traditional approaches to advanced analytics and machine learning, what we do is we move the algorithms to the data, and that is intended to imply that we're moving the algorithms up to the cloud. So if you have Oracle database or Oracle Big Data Appliance up in the cloud, you already have, if you read the fine print, all the machine learning algorithms are in there as well. So we have a lot of lawyers at Oracle, and we're always required to show this safe harbor statement that says, if I'm talking about anything that's sort of futures, ignore it. It's just not sort of real. Now, this is all what was futures, but is now shipping. So I don't believe I'll be talking about anything that's really futures here. But if I happen to slip up, then this disclaimer does apply. So this is the overall lay of the land, sort of the state of the art of what we see out with most customers. They have data in maybe an Oracle database, hopefully an Oracle database, but sometimes it's going to be other different databases, Microsoft, IBM, Teradata, who knows what. And you also see different vendors, Oracle and otherwise, for Hadoop platforms for storing large amounts of data in Hadoop. But when it comes down to the analysis of that data, the first thing that most customers do, just because they think they have to, not that they do need to do that, but just because they think they have to, is they take a copy of the data and they export a whole patch of data out of these systems to SAS or R or SPSS or MATLAB or you name it. They'll take it out of a very fine, well-behaving, well-performing data management platform and take it somewhere else, a totally different sort of environment and platform, software program, just to do the analysis. And what we say is, if you can believe that we could calculate, say, Charlie Berger and his age and take the square root of his age and do that in the database, would you please believe that we could also do a neural network on predicting whether or not I'm likely to buy a Buick or likely to commit a crime or likely to buy a product or whatever? I've taught the database how to do about 30 machine learning algorithms, and I've taught the Hadoop platform how to do about 30 machine learning algorithms. So now I can move the algorithms to the data, and I don't have to go through all of this sort of outer loop. And there's a lot of problems with the outer loop. You have duplicated data, data movement, no single source of truth, security challenges, backup challenges, more space and power. It's just sort of a mess, right? So if you don't need to do this, then why do it? So we say stop the madness. This makes no sense. And what we say is that we have a platform. So recently I rediscovered this Dilbert comic. Dilbert always has something appropriate to say on the current topic, and he came out with this comic a while ago, but I recently rediscovered it and I thought it was hilarious, so I threw it in here. And basically, I won't let you read it, but basically Dilbert says, I'm working on a framework to allow the construction of large-scale analytical queries on unstructured data. And she says, I'm a little turned on by that. And he says, settle down, it's just a framework. And that's my point here. It is just a framework. We don't have a off-the-shelf tool for, say, anti-money laundering. We don't have an off-the-shelf tool for a recommendation engine. You can do all of those kind of things, and I think more easily than you could any other way, but you can do those using our framework, using our analytical platform. So this is what most people do. The traditional approach to data mining, machine learning, predictive analytics, knowledge discovery, whatever you want to call it, cognitive, whatever you want to call it these days. The first thing they do is they take the data out of wherever it's being happily stored and they move it to some other tool. And you can pick the tool, Stata, SAS, JUMP, Minitab, SPSS, H2O, R, you name it. People are going to take it somewhere. The tool that they learned in college or the tool that they just recently downloaded or their company purchased, and they're going to do all their analysis, but they have to take a copy of the data out to do the analysis in this other environment. But what we say is don't move the data. Did you know that database or that Hadoop platform, it's smart now. It's not a dumb database, because who wants a dumb database? It's a very smart database, and it can do a lot of cool things. So when you really look at what's really going on in the traditional move the data, if you solve a problem, let's say which employees are likely to voluntarily churn, there's a lot of inputs and derived variables, what we sometimes call engineered features, that go into that. So you oftentimes are getting data from other locations, maybe sensors, maybe devices, maybe other databases. You're deriving variables like what's my bonus amount this year versus last year, maybe the difference between the two, and maybe compared to my peers, right? All those sort of derived variables and the access and the sort of tentacles out into all the different various sources of where you might have the best data to solve a problem. Well, that makes this whole process kind of messy, right? There's a lot of different components involved with that. And what we say is our data management, that's now a smart analytical data management platform, be it Hadoop or database, or both using Big Data SQL. What we say is we have a simpler, smarter data management and analytics / machine learning architecture. So a lot to say there, but it basically says our data management platform is now a combined data management and advanced analytical machine learning platform. So we move all these features and functions inside the database or inside Hadoop, making a much simpler, more powerful architecture. That's our sort of reason for being. That's our competitive advantage over pretty much everyone else out there. So here is a continuation of a quick overview of what we have today. Today, whether or not you have the Hadoop platform and you're storing your data in a data lake, hopefully an Oracle data lake, or in the sort of ever popular Oracle database, where a lot of people store their data as well, we've moved machine learning algorithms, statistical functions, R integration, and so on into these two platforms. There's slightly different implementations because of the technical differences between how you would implement something natively inside of a relational database and how you would implement something natively inside of Hadoop using Spark and using MapReduce and so on. So these algorithms today are slightly different. We're looking to, over time, sort of converge those things as best possible. But if we have a logistic regression here, we'll also have a similar logistic regression over here. That's pretty much the way we operate. And so these are taking advantage of all the features and functions of the database. So they can also use Oracle text to tokenize unstructured data, so we can ingest and mine unstructured data. If you have transactional data, like I know I was working with one customer that was looking for medical fraud, and they had transactional data like prescription fraud, and they had people who had OxyContin prescriptions. Well, if I, charlie.berger, am having 100 OxyContins, maybe a derived variable might be aggregating all of the prescriptions across all the different types of prescriptions, but now for OxyContin, what's the median amount of OxyContin that most people take in the training population? What's my amount of OxyContin? And do a derived variable that's the ratio between those two. And that's a cleverly derived engineered feature that I can very easily do inside the database or using Hadoop or using Big Data SQL to combine those two sources. And that's a very, very interesting variable to push into whatever machine learning algorithm I want to use. And as I said, we have about 30 on both platforms. So I kind of glossed over Big Data SQL there, but Big Data SQL is one of the things I consider to be yet another one of Oracle's sort of secret sauces out there. And what Big Data SQL does is it extends the functionality that came out of the Exadata technology, and it pushes down the predicates. So it's called predicate pushdown. So in the database, we use this predicate pushdown to say only pull off of disk, if you will, just not into the database memory and into the database software itself, but just off the hardware, off disk. Only pull up if I have a query that says select all males who are greater than the age of 40 and whose last name begins with B. Well, that's a query that would get pushed all the way down to the hardware. And in Big Data Appliance, our Hadoop offering, that same query would get pushed down to the Hadoop platform and only be pulled up off disk if it were appropriate. So we push down the predicates in both Hadoop and in the database, and that just leaves a lot more I/O available for doing other important things. I don't have to do all the filtering and selections inside the database, or I can do them on the data management platforms themselves. So if that's our sort of analytical and data management platform, it's a combined Oracle data management and analytical platform, who are the users? Well, I contend there's two different classes of users typically. There are the information producers. These are the people that the data scientists, the R users, the citizen data scientists who do the data analysis, who try to gather the right variables, who experiment, who prototype, who maybe do a data lab and do a fair amount of experimentation and building predictive models and kind of vetting them with others. Maybe it's a credit risk model, maybe it's a healthcare model, maybe it's a fraud model or a recommendation engine kind of model. And these information producers are sort of down and dirty with the data in whatever data management platform. And they know the difference between a mean and a median, and they know the difference between a neural net and a decision tree, and can use some or all of them in various combinations. So they're doing all the analysis. Over here, I'm showing Oracle Data Miner, which is our extension add-in to SQL Developer. So SQL Developer has something like 1 or 2 million downloads a year, and in those SQL Developer downloads is embedded Oracle Data Miner. The Oracle Advanced Analytics, by the way, is already embedded in the database. It's bundled in the cloud. I think high and extreme editions of the cloud is just bundled in there. So I download SQL Developer and I connect up to my database, or I download RStudio, which is what most people use, and I use the R API to access the same functionality. And you can do that with either the database, or we also expose the algorithms on the Hadoop platform via only the R API at this point. So these are your and if you're using the GUI, by the way, it also generates the code, so I can go directly to deployment, which is a very powerful feature and really a differentiator for Oracle. So you can go beyond the data scientist. And then now the other people that are important in this are the information consumers, those people who might be using Oracle's or perhaps other vendors' offerings for business intelligence dashboards or various applications that they now want to make predictive applications. And I'll touch upon just a little bit of this later on, I believe. But the idea is that usually these dashboards or applications, they're querying data in the database or maybe on Hadoop, and they also want to get access to the predictive insights and the predictions and the models. Well, they're not, this skill set of people over here are usually BI analysts, managers, functional users. They're not really these data scientists, citizen data scientists. So they really sort of would work with and depend on these people to do the analysis, leave the results in here in the database or in Hadoop, and then let the information consumers more easily see, here's the pie chart of all the different profiles of people who are likely to buy my product or to churn or whatever. So if you move the algorithms to the data management platforms, it makes it much, much easier to do this, and also to go even further and build what we call predictive applications. And we've been doing that and have, I think, over 15 predictive applications in the marketplace out there already today. So what we've also been doing is I said, moving the predictive algorithms into the applications, making those predictive applications. So that's a pretty cool thing to do. Here is the list of all the machine learning algorithms that we currently support. Now, this is a little bit of a blur. It's the union between everything that's on inside the database and in the big data appliance, both on cloud and on-premise, in cloud and on-premise. But there's a strong overlap. So I just chose not to put it on two separate slides because there's 90% duplication. They are different implementations. So the generalized linear model or the random forest that runs inside the database is a slightly different, or very different actually, implementation of what one runs on Hadoop. But you'll get your trees and your logistic regression models ability to run on either platform through the implementations on both platforms. All of the algorithms, as I said before, they all support text as well. So, as I said before, we use Oracle text to tokenize to give the data. So it gives us a vector of terms like discount and savings and all of these happy, sad, all the different words, and we'll know how often somebody says those words or terms versus the larger population. And in release 12.2, we've gone a little further and we've added something very, very powerful called explicit semantic analysis, and I'll talk about that in a minute. We've also added in the new release this unsupervised pairwise Kubler-Leibler divergence algorithm. And what this is it's a derivative of the expectation maximization algorithm that we've already had over here in clustering, the expectation maximization algorithm. And what we do is all of the attributes that are used to create the clusters we deem to be important algorithms. They're the ones that have some sort of information gain in them. So regardless of whatever target field I may be looking at, I can just say, well, you know what, I don't know what I'm going to do with all this data, but I got 2,000 variables here, and I'd like to just pick the top 500 variables that are most of interest. And I could put this unsupervised pairwise divergence up against data in the database and filter that down, winnow that down to a subset of variables. Or I could, using the external features in Big Data SQL, I could do the same thing on the Hadoop platform and say, well, I've got this data lake. What are the variables in this data lake that I might want to keep around because they're of interest to me? So we have a wide range of algorithms. We have unsupervised anomaly detection. We have 3 different types of clustering algorithms. We've recently added the random forest functions that are exposed currently via the R API only. And then we also have, of course, one of our real strengths is the ability to integrate with open source R. So you can access all of these algorithms using the GUI for the citizen data scientist, Oracle Data Miner. You can go natively directly to the SQL APIs to drive all these things, or you can go to the R APIs to drive all these algorithms. And because of our tight integration with R and something we called embedded R, if I ever want to do a call out, like a remote procedural call, and call an external package and have the database control that, maybe handle partitioning, maybe do a lot of the aggregations inside the database, I can always do that. So I can use any R package. If everything I was going to do was going to be primarily outside of the database, maybe this is not the right way to go. But if I want to do all of these things here, and then a few other things or some experimentation, this is a perfect way to support those kind of needs and requirements. And then also on the Hadoop platform, we've been exposing and wrapping more and more of the MLlib algorithms, the Spark MLlib algorithms, and we expose those to the R API. So I can use RStudio, and I can access logistic regression of Spark ML, logistic regression, and so on the Hadoop platform. So that's our overall sort of union of all the algorithms today. Now also, because these are in the database, as I said, they can mine unstructured data, they can mine transactional data, as I said, but you can also, one of the new features in the database, 12.2, is something we call partitioned models. So just like you can do a partitioned query, like show me all the ages of the median average of the males and the median average of the females in the database, I could say, and partition by state. And now I would get 50 different values for each of those attributes because I just say partition by state. Well, I can do the same thing now just using the database infrastructure. That's the benefit of having moved the algorithms to the data management platform. I can do partitioned models by region, by gender, by whatever. So I'll show a little bit of this as we go through the new features. So still a little bit of overview. If you look at what we have to build a predictive model, usually you assemble a bunch of data, which might involve some historical data, maybe some sensor data, some unstructured data, some spatial transactional data. This could be coming in from a data lake perhaps, or from the database, or both. I may have a bunch of engineered features, which are the ones I talked about before with the OxyContin or the bonus amount compared to my peers. And these are all sort of cleverly derived variables. And people that do this in, say, other traditional statistical analysis package, I know oftentimes, I'll say proudly, tell me that they have more data in their traditional statistical analysis package than they have in our Oracle database. And I can understand that, because to do all these derived variables, to do all this cleverness, the data scientist, the analyst, the statistician, they need to have the access to the data, and they have to have the freedom to do the derived variables and all the analysis they need to do. Well, if all of this is sort of happening inside the database, and the data analysts are allowed under the close supervision and control and support of the DBA to have access to that data that's encrypted, that is able to be queried in a parallel scalable function with 500 degrees of parallelism and so on, that data analyst, the citizen data scientist, is able to do their work in a much more productive, powerful environment, and this collapses the whole sort of outer loop that people do. So I think almost last summary slide here. So what we offer with our machine learning and advanced analytics in the data management platform is we forego this whole need to export the data, to take an extract of the data, and then do some analysis and do an import of the results. We collapse that down to a much faster, parallelized in-database or in Hadoop implementation of those algorithms, thereby leveraging all your huge investment in Oracle technology. And we support data scientists, citizen data scientists, application developers, R users, all of the above. We're what I call sort of trilingual. And in doing this, in sort of collapsing this whole thing, most of the customer references that we have, they have a common sort of theme. And they'll say, what used to take me sort of weeks, I can now do in minutes, hours, or maybe a couple of days. And this is not meant to imply that this is the time to build the model. This is really most realized by the fact that you don't have to do this outer loop to do all of your model deployments. I can, if the model is built inside the database, then deploying it as a real-time recommendation or a real-time predictive model, or undergirding some sort of airline reservation system that uses the Oracle database in an OLTP environment, well, it's easily done because the models are part of the data management platform. So this is our real differentiator. And so in summary, we have a library of about 30 machine learning algorithms on both the platforms. They run in the native environments where the data is managed, so you don't have to move the data. We support a range of users, people that may want to use the Oracle Data Miner GUI, people that may want to use R because they came out of school or they recently learned R, they like the freedom of that, and then also application developers because they want to deliver scalable enterprise-wide predictive analytics. So in doing this, what we've done is we've sort of extended the library of SQL to include things like select, where I can group by, and where I predict or detect or cluster. I've just extended the library of SQL or R, because I can be bilingual here, SQL or R to do this. And I've just turned or transformed or extended my data management platform into an analytical platform as well. Oh yeah, a couple of more slides here. So we also handle unstructured data. I claimed that earlier. I wanted to kind of show this. So here's what we do there. Shopping at your store is a hassle. I rarely shop there. What we do is we tokenize all that, and then in the graphical user interface, Oracle Data Miner, all you do is just say text. That is text, and then that runs off and automates the tokenization of all that, the TF, IDF, term frequency, inverse document frequency, and off it goes. So and I think that's the last overview. So with R, people often ask, well, how do you use R, and how do you move all your 10,000 R packages to parallelize them inside the database? That's not what we do. That's not what we really claim. What we claim and what we do is that we take the base R language and we transparently map the base R language. So if you say aggregate or do a derived variable x times y or something, all of the base language R and the base arithmetic functions and so on, that gets mapped transparently, invisibly to you. It gets mapped transparently over to SQL. So when you write your simple R scripts, they get mapped into simple SQL equivalents, and off they go. And if you want to run any machine learning functions like a decision tree or a random forest, we'll say, well, don't use whatever R package you can just find by going to the CRAN and downloading any old R package. look at what we've already implemented inside the database and use ours. So now if you stay within 1 and 2, you can do all of your data mining, your machine learning inside the database using our highly performant parallelized implementations of those decision trees, clustering, logistic regression, text mining, and so on functions, but you're using your very familiar R language. So your team of data scientists and citizen data scientists can be sort of multilingual. They can speak R, they can speak SQL, and they can speak GUI. And if you do need to do some sort of call outs to anything else, we support through the embedded R call out capability. You can spawn any database function to take the data, parallelize it, task parallelize it, data parallelize it, and run an R package that's outside of the database, running on R serve that might be running on the same server as the database is installed. So you're moving perhaps less data a shorter distance on a very powerfully mounted R server. And then you can return the results. Or if you've built a model in R, you can actually call that model back and execute that as an ORE group apply for very high performance scoring. So it's a very, very powerful, tight integration with R. I think it's the tightest integration that's available in the industry because we push down the R language as best we can into our equivalent in database implementations. So now, finally, after 25 minutes, we're into the new features of 12.2 and Oracle Data Miner 4.2. So I'll cover these. If you're watching this, I should probably make a note that you could just jump ahead to this if you just want to cut straight to the chase, because some people already know the first part. But I found that it is important to kind of lay the groundwork for what we already have today. So at a very, very high level, we've added what I guess you'd say 4 or 5 different new things. We've added some new machine learning algorithms. I'll cover those. One of the main features was significant model build performance improvements. Everything is like orders of magnitude faster, and I'll show that. We also added the partitioned model, so I can build models, say partitioned by region or state or gender or all the above. And then all these server-side functions from release 12.2, of course, they have to get exposed to the graphical user interface as well, so that Oracle Data Miner picks all those new features up and exposes them in release 4.2 of SQL Developer. And the net is what we always say, we now still have a data management and analytical platform that can enable predictive applications. So going into a little bit more detail, the new machine learning algorithms include the unsupervised feature selection. Now, this is really kind of cool. It's using the callback-Liebler divergence. You don't have to say that or know that, but it's just called an unsupervised learning algorithm that says, for all the numerical and categorical variables, I want to find the highest information containing variables. And we expose that, of course, via the SQL API, the native SQL API, but also through the Oracle Data Miner GUI. So what we've done here, I'm just going to cut over to the demonstration here. I have what would be a typical Oracle Data Miner workflow. This is using the customer insurance build where we're trying to figure out which customers are likely to buy what. Well, if I have this with a buy insurance, then that's what it does, right? It says with that as a target field, what is it what are the variables that are most correlated with that? But now what this other feature does is it says, I don't know what I'm going to try and do here. So it's the same thing. It's the same node. I just wanted to not tamper with the other one that's already run. So this one just says what attribute importance. I want to run attribute importance, but I don't have a target field in mind. So that now launches the callback-Liebler divergence. And this says these are all the variables that, regardless of what I'm trying to do, they have some amount of information gained. So if I have a data lake or if I have the database and I just have lots of variables, and I have 10,000 variables. I could chunk this. I know the database only stores 1,000, but I could have 10,000 variables and chunk it. I could take things off the data lake and take a shallow drink and figure out what are the variables that have any kind of value add. So a lot of people will do this with graphics, and they'll show scatter plots and histograms and graphic after graphic after graphic. What we do here is we use some machine learning in an unsupervised learning kind of implementation or approach, and we say, I don't know what you're up to, but these are the variables that seem to have the most relevance to almost any kind of problem. Now, if you know exactly what you're going to do, you want to do this. Okay, you want to do this, the supervised one, and then here I go off and build at least 4 predictive models, and off I go. But here, I don't know where I'm going to go with this thing, but I just say I just want to figure out what are the variables that are really kind of key that I want to keep, maybe put into dashboards, maybe save around longer. I don't know, but that's the main point of it. Lots of data and I want to kind of winnow that down to the data that makes the most sense, or has the most information. Now the next one is the association rules enhancements. And what we've done on that is we've added the calculations associated with the values of the association rules. We did this for our own Oracle retail business unit and a major restaurant type of customer, I guess, that had asked for this. And they said, look, I do all these market baskets and I have beer and diapers, but I really then need to do a second process to calculate what's the dollar value of all that. So now if you say, well, the beer costs this, the diapers cost that, the hamburgers and the buns and the ketchup, all these different items, I've dollarized them. Then in the same pass through the data, we dollarize all that. So now your market baskets are a lot more sort of meaningful from a business sense. The other thing that people have often given feedback on for the market basket analysis is that if I have 10,000 items in the store and in my SKUs, and I want to do some analysis, well, maybe I'm only looking at women's shoes and what socks or men's shoes and what socks goes with or hats or scarves, whatever go with that. So now I can filter before or after the inputs and the outputs, so I can build the model on a lot less data. So here is your traditional market basket analysis over here, and I'll just view the models, and I can see, what goes with what. If you buy this, then you're also likely to buy that. And I have a bunch of different things that sort of go together here, and I can query this and say, well, I'm only interested in things of a certain things like where is it here? I'm only interested in things of a certain item. Like shoes or socks or whatever. Well, I've always been able to do that, but what we've added in the new release is the ability to partition or filter these models. So I can filter them now and say, I'm just interested in, say, mouse pads as the antecedents and consequence, something to do with laptop carrying cases. So then it's just going to build a model based on these inputs and these outputs. And I could also add other things here to exclude. I could say, well, I don't want to include everything, so I may want to exclude certain things here, and I just add them, pick them, and add them down there. And so it's a nice way to kind of more intelligently work through the data. Now notice I also have this channel, so I can go over here and say I want to partition by channel. I could partition by region, so I could say what goes together in Texas is different than what goes together in Massachusetts, and California is yet another region, so I could do those kind of things as well. So that's a very, very powerful enhancements for people who do market basket analysis. It's one of the other new algorithmic enhancements that we've done. The next one is the significant performance improvements for all the algorithms. And I have a slide on that in a second that I'll go through. But all of the algorithms have been sort of re-engineered, overhauled. So now they can scale to huge volumes of data, huge number of attributes, and for the kind of volumes you found on premise, but also in the cloud. And I'll have some performance numbers on that in a second. And then the other one I've talked to a few different times is the partitioned models. So instead of building and naming and referencing, let's say tens or thousands of models, let's say models of who's going to vote in the election, males from Texas versus males from Idaho or something, right? Well, now I can just say I want to build a predictive model partitioned by gender and partitioned by state, and it'll build me, 100 different models. I think I've already sort of shown that, but I'll show that back in my classical machine learning using the by insurance one here. And if I just go up here to this and I say partition by, I could just say I want to partition by, let's say, I think I have region here, region. Or if I want to partition by region and gender, well, now it's going to build, I don't know how many regions are in here, but now if I run this thing, it'll build, let's say 100 different models. And when I look at the results, they'll all be sort of tabbed, and I could kind of scroll through all the different, the males in Texas versus the males in California, the females in Texas, females versus California, and so on. So that's that. Now, in terms of performance, unofficial numbers, but if you look them on the Spark and Solaris T7, they're a little bit faster than they are on the Intel and Linux X5s. And these are numbers that come out of Oracle Engineered Services testing that we work with. And notice that this is millions. This is millions of records. So if I have 640 million records and I have a properly sized machine, 512 degrees of parallelism there, I can build an attribute importance model in 28 seconds. I can build an expectation, a k-means clustering in under 3 minutes. I could build that naive Bayes, that simple naive Bayes algorithm. I could do it in 17 seconds. Notice this is for the model build, which I've always contended that, if model builds a problem for you and it was running 2 or 3 hours or something, or 4 hours, which rarely happens, you could always just schedule it. You just say, run it at night, run it Sunday night or something. But now you could still schedule it, but look at the performances here. I mean, you're talking about 1, 2, or 3 minutes to do these kind of things. And my point on that is, wow, that is fast. So, the developers work very hard to re-engineer and overhaul all these things. They're taking advantage of all the strengths of the in-database. We have similar kind of numbers on, or similar kind of fast results on the Hadoop platform and the big data appliance, but I'm primarily talking here about the new 12.2 release and the 4.2 database release for these particular numbers. But I've always thought, as a data scientist, a data analyst, I know guys that tell me under great stress that they're on the hook to do 2 or maybe 3 predictive models in their jobs for that year. And I'm thinking, wow, I could do 2 or 3 predictive models in a week if I'm getting these kind of performances and I'm allowed inside the database to do my analysis. So here's another new algorithm. So this is, I guess, the third new algorithm. I'm not counting, but this is at least the third new one. This is something called explicit semantic analysis. It's a useful technique for extracting more meaningful, more interpretable features out of your data. What we do is we use the English Wikipedia as a text corpus. So we'll sort of take a known corpus of information that might say, well, Boston, which is where I'm based, Boston is not only a city, but it is associated with Boston baked beans, maybe Boston cream pie, and there was a baseball player named Boston at one point too. So all of that is all sort of known. So if I'm talking about, the town of Boston, and I love their pies, well, maybe it's a Boston cream pie, maybe not, but I can use that information. That it's not just a noun, it's just not just an unknown varchar. It is a token with meaning. So if you look at these two documents here, even though they don't all say the same thing, and they don't say Osama bin Laden in the second paragraph, using the explicit semantic analysis algorithm and the English Wikipedia as the corpus of knowledge, we can compare these two documents and get something like what's called an ESA similarity score. So we can say this document or this tweet or this blog or this resume summary description is very, very similar to the summary description of the ideal candidate I'm looking for. So this does not have to be any one thing. You don't just run the ESA algorithm. You could, but I contend that you use the ESA algorithm to do a lot of sort of clever and interesting things, including generating new derived variables as part of my analytical methodology to maybe, I don't know, find the right candidates for jobs or find the right individuals for an assignment or whatever I'm trying to do, right? So I'm able to take much more meaning out of the unstructured data. And here's a little bit more on that. It's also doing topic identification. So here's a paragraph up on the top, and the topic includes concepts, peoples, organizations, events discovered through ESA using the Wikipedia as a model source. You see the recession, Ben Bernanke, last decade Japan, but instead of using the entire Wikipedia, we also can limit ourselves to the source data set comprised of concepts only, and we can narrow that down even further. So it's a sort of way of boiling that down. I suggest if you know all about this, please use it. If you don't, you might want to take a look at it. In the user interface, and we've sort of wrapped a user interface around parts of this. So over here, if I go over to, you may want to go beyond what we provide in just the user interface. But here we have a small sample of Wikipedia data, and I use the explicit feature extraction build. And now if I look at the models that I've created here, and I say, well, I'm looking at, let's see if I can get this guy's attention here. If I look at this and I say, I don't know, let's just take Abraham Lincoln. Well, now I see all the information about Abraham Lincoln here, and I can see these are the items. And if I look at this in terms of the coefficients, so these are the terms that are most associated with that knowledge base about this fellow Abraham Lincoln. And if I take the coefficients here and I sort of push that into a tag cloud, I get sort of a tag cloud. So this I think is very cool, but I think it's also a piece of the puzzle that you would use in a larger analytical methodology to solve problems. So you can do certain things with the GUI, and you can do even more by sort of embedding it as part of your analytical application. And you see this nice little use case here that was actually, I stole this from a very good consultant, Brendan Tierney, over in Ireland, who's written a book on Oracle Advanced Analytics, and I stole this from his blog. So Brendan, thank you. But this is an example of some of the things you can do. Now, R extensibility, we've added the ability to register R models as in-database models for the build, apply, settings, and viewing. So this extends the ease of use for building and deploying R models inside the database. In the new implementation, if your R model can support the concept of nested attributes for handling text and aggregated data, then now, of course, the database knows how to do that. And in the Oracle Data Miner build node, we have an ability to go add. There it is. Have the ability to go sort of add new models. So how do I get these models here? I might have a new model here, but the build function would be a selected registered R model. So I have not done all this yet here for this quick little presentation and demo. I'll have to do that soon. But this is now using, from over here in the documentation, it's using the R build, the ability to register a model, and in R there's this sysrq script create procedure where you sort of take an R model that you've built and you register it. So the R model has to sort of have certain inputs and outputs. It kind of has to adhere to the disciplines that we adhere, that we make our other machine learning models inside the database adhere to. So there has to be a model signature, there has to be a model details and so on in your model, but this goes into the details of how to go about doing that. So that's a nice way to sort of bring these things closer together and leverage the strengths and power of the database for your R models beyond what we already do today. So that's the extensibility for R, and just sort of kind of wrapping it up here. So in general, all of the new 12.2 features are now exposed in the Oracle Data Miner 4.2 user interface. So I have everything I've just shown you in the server side is now exposed in the GUI. And one of the coolest ones, I think, well, they're all cool, but this one I think is very, very cool. Oftentimes I build a workflow and I just want the thing to run every Saturday night to build my models, and then maybe score my customers, I don't know, every Monday morning, every day of the week at noon, whatever I want to do to build some sort of analytical methodology. So now, just like Microsoft Outlook scheduling a meeting, I can go into Oracle Data Miner and come up here to this little calendar guy right up here and create a schedule and say I want to do all the nodes or whatever. This one's not all fully defined, but let me go over to this guy here and all the nodes here, and I just want to say I want to schedule something here, create a schedule, and I can do all nodes and say I do all nodes, and then it says when do I want to do this, and I have a schedule I can use every day, every week, and just set this whole thing up just like I would do setting up a meeting. And then I can also say who I want to have an email sent to that this was completed, and so on. So not going to bother setting that whole thing up right now, but so that's the new scheduling feature. And then what I always like to say is it's more than just a tool, guys. We have machine learning functions that transform our data management platforms, the database and Hadoop, into analytical platforms. So you can do so much more with that. And so now that decision tree that I showed earlier, well, that decision tree, that's appropriate for a data scientist, but not for a functional or domain user. So here's now the decision tree, the tree node rules all displayed as pie slices. So that's a lot more intuitive. I can click on the pie slice and drill through, and the Oracle data visualization users can do much more with this than I can. They can maybe place those predictions on a map. They can do all sorts of cool things, but the data science was done by the data scientist, and the data visualization and the information presentation is done by those BI specialists. So I always like to point that out as one of the real, parts where people sometimes get confused, and that's my point of view on that. Let's separate those two tasks a little bit more. And if you do that, then you can do things way beyond that. So here's something we've done, one of my favorite applications, because it just is one of the first ones we did, and it's just hearing of more and more customers that are now using this. where they have all of their employees in the Oracle Human Capital Management application. They're all running up on the cloud, and they may have managers in a hotel chain. They may be financial analysts at a financial company, and they don't want these employees to leave. They may be software developers, and they want to know who these people are. So Oracle HCM has a module called Workforce Predictions, and it leverages all of the in-database features and functions. So all of the stuff that I showed before, it's kind of invisible, but under the hood, if you peer under the hood, there's a lot of math and a lot of analytics that are going on. But notice how much simpler this is than if I were to do this the other way, where I was taking the data and moving it out to SAS or R or SPSS or MATLAB or MLlib or H2O or whatever. Now my data management platforms on-premise or cloud are now very, very smart analytical platforms. So that's it for all the new features. I always like to close with, how do I get started? And I have a lot of different links. You can take things on. I have links on how you can get started with training materials and tutorials like this one, and links to the documentation, white papers, the works. And if you can't, and also, I guess I need to update that. It's BWA Summit 18, which is January 30th, February 1, and January 30th, 31 and February 1 of 2018 out at the headquarters. So just Google bwasummit.org and you'll see the latest on that, where we all get together and share best practices and novel and interesting use cases. So anyway, if you cannot remember all this, just send me an email at charlie.berger@oracle.com and just say, send me the links, and I'll send you a bunch of cool links so you can get started with this stuff. And that's the BWA Summit 2018, and those are the dates there. So please try to join us for that. It's only, say, $400 or $500, $500 or something to go. Get the early bird special. You get in there, and we'll have 3 days of about 500 people, all talking about big data, analytics, BI, spatial, cloud, IoT, everything cool. So how customers put all these interesting pieces together to solve larger problems, more than just a query and making a pie chart type of conference. So thank you for your attention. We can't really do any questions. If you do have any questions, please send me an email at charlie.berger@oracle.com. Thank you very much for your attention, and I hope you enjoy using the new features in Oracle Advanced Analytics 12.2 and Oracle Data Miner 4.2. Thank you very much.